Thank you, Jesse, for the introduction. Just to build up on that, I'm Anand. I'm like Jesse said that I'm a data scientist within the financial crime and RegTech department within ING. And today, with with my colleague Mickey, I would present our product NLING, which used to be called Natural Language Interfaces for ING, but I thought that it did not really roll off the tongue, so we shortened it to NLING. It's a full text search engine built on top of Elasticsearch, and we spent quite a significant amount of time last year in 2020 to bring it into a test environment on the cloud and make it available to our stakeholders. Without further ado, let's begin. Just to give you a quick structure of the talk, just so that we can also make the time. I will start with the introduction to the product, and let's come to the agenda. We will start with the introduction to the product, and then Mickey would walk everyone through a little bit of infrastructure concepts, which will come in handy during the rest of the talk. And then we will talk about how we deployed like one unit of our product, which is a microservice, and then Mickey would talk about how did we deploy our central app or a conventional backend on the cloud, and followed by the front-end development, and we will conclude with some final parting words. We kept this GIF in here because it really captures any software engineer sentiments, in our opinion, who has tried to work on a deployment journey for his or her product. Okay, so moving on. All right, so like I mentioned, that NLING or Natural Language Interfaces for ING started as basically a product for dealing with unstructured data. And just to give a little bit of context, as a department, we mostly deal with post-transaction monitoring, but we also deal with some customer screening and so on and so forth. So this entire product was built for customer due diligence. So with that in mind, we will be dealing primarily with unstructured documents, and unstructured documents vis-a-vis, in our case, it was PDFs. However, they were properly digitized PDFs. So just to refer to the previous talk, OCR, for instance, was also something that we tinkered with, but here we dealt primarily with well-formed and well-structured digitized documents, so we didn't really encounter that. But what it started out with was this one product with various features as required by our stakeholders, all built into one application. And basically, in that application, we had like a monolithic kind of a structure, and what we started realizing as we added more and more features was that the features were fairly independent of each other, and second is that they were basically making the application very heavy. So in the end, when we packaged our entire application in a container, it was about 7 gigabytes. Problem hosting it anywhere. Also, if it, for instance, there is any issue, difficulty debugging, restarting, and all sort of things. So we eventually broke it down into different steps, because we realized that each of them were also sequential. Like we first uploaded a document, it needed some kind of pre-processing into well-defined data structures. Then we needed to vectorize it, get a numerical representation of the text. We had to think about the storage of these vectors, let's just say, and we had to also think about how to show them. We had to think about compliance and operational aspects. So we broke it down into these models into basically microservices, and that's what you see here. You see that the green boxes are microservices. First is the preprocessor, which basically ingests a PDF document and breaks it down into paragraphs. The second one is the vectorizer, which ingest these paragraphs and converts them into a numerical representation, in our case, a 512 dimension vector. And then finally, there is a ranker, which given a query matches against these blocks of text and basically gives us a ranked list of answers from the documents. And then we have the central app, which is the central orchestrator for all these preprocessor. It's a Flask service, basically built on top of Elasticsearch, which is just rerouting our requests. This is followed by the front end, which is in orange, and that's where the stakeholder interacts with our product. Now, moving on to some details about the infrastructure. Mickey?
Yeah, so as Anand briefly explained, we separated our application in three main components: the microservice with one in and one out, a web application, which isn't really something like dashboarding, but really like a full-fledged progressive web app. So you need some user management, user authentication. And of course, the backend, which tries to outsource all the heavy lifting, but does need some persistent storage and some business logic to make all the components work. So the infrastructure that we're going to describe here is also very based on these three main components. So try to briefly explain those three elements and how we deploy these without going too much into detail about, let's say, the specific departments and implementations within the organization itself, because they're quite abstract and can be found anywhere. And as you will also notice, maybe if you're working at ING, is that there are way more infrastructures out there than that we're just going to describe here and that we actually use for the application. So in the presentation you see here, you see the infrastructure itself mainly consists of the internet as a whole, but then the ING internal network as a place inside that network. And this is important because, you know, this ING network is not safe or secure or compliant in any way. So if you're going to host any application, you would need some more stuff on top of that. So that's where the touchpoint service mesh comes in. And it tries to deliver some rules and some standardizations to communicate in a secure and compliant way between applications. And this secure and compliant way for this touchpoint service mesh, at least, means that you would have to apply for an API. So you need to register your API, say, hey, I'm going to produce something, has 20 endpoints, or I'm going to consume an endpoint as well. And that these things would go through the API marketplace. But you would also maybe need to solve the issue of tackling different types of distribution methods. So it could be distributed over multiple containerized applications on different machines through Kubernetes, for instance, or just a virtual machine that you are assigned to. And service discovery handles this by basically saying we're going to abstract away all these direct DNS or these IP addresses that you're using, and use logical connections, and they handle then the connection to the right machine for the right time. In addition, you would also have MTLS as a certification requirement. So you also would need to be able to communicate in a secure way. And this is where MTLS comes in. So MTLS is a mutual TLS, where both the consumer and the producer would need to confirm each other's identity. And all this leads into basically that you have multiple ways of communicating in only just the touchpoint service mesh. So this is already quite a big requirement to start even communicating between different applications. So to tackle this, you also have something that's called a sidecar. And a sidecar is not like an application per se, but you can see it as an assistant or like a proxy that runs next to your application, tries to abstract away from all these tasks. And this could mean that you the sidecar will handle the MTLS certificates, the service discovery, and in this case, have the right configurations for this API marketplace. But it could also be that your applications exist completely outside of the scope of the touchpoint service mesh. In this case, you would need to be able to communicate in a compliant way for the service mesh, but also outside of the service mesh. So what that means for our application is that we had a VM, so this was our central backend, and that runs outside of the service mesh, but we needed to use or build a sidecar that could communicate within the service mesh, because we also had a web application, which is a bit more than just dashboarding in our case. So we really wanted to separate the deployment of that and went for the front-end server delivered by a separate team. But that meant that this entire application ran inside the touchpoint service mesh and would communicate only through the NGINX gateway, which in ING acts as the barrier between the internal network and the external network, but also many applications between that. And then we had our stateless microservices, or sometimes models, and these needed to scale a lot, so we wanted to deploy them on their separate machines in a scalable manner. And that also meant that we had to put it outside of the touchpoint service mesh, but also had to communicate, of course, back to the central backend, which was placed inside of the service mesh. Hopefully this gives you a little bit of an overview of how this infrastructure works, but you can imagine that you might deploy your microservices outside of the scope of the ING internal network at all. So it could be that you're running this on GCP, on the Google Cloud Platform. And in these scenarios, you would also benefit from having, for instance, a sidecar, because then you can place that one inside of the service mesh, maybe a proxy that communicates through the gateway, and that way connect basically your applications together. So further on, we're going to discuss deployment of these three services. And what's good to keep in mind is that all the steps that we basically do relate to connecting these applications together. Of course, there are many different journeys depending on the infrastructure that you choose. So I'll leave it to Anand.
Yeah, thanks, Mickey, for the very succinct and clear description about these wide array of infrastructure concepts. The building block of our application was, like I mentioned previously, a microservice, which was, let's just say, basically a very independent aspect of the product itself, which we broke down into, or a model, let's just say, which we spun off into a different service itself. And the core concept of this was that it was receiving one kind of input and it was producing one output, and we needed a place to host it in the cloud so that it is scalable and fault tolerant, and we also got some individual monitoring on them. And then therein basically came the machine learning platform, which is a squad within our organization, which helps taking machine learning models to productions. And because all of our models that we mentioned here, the preprocessor, the vectorizer, and the ranker were machine learning models, we naturally turn to machine learning platform. So what they provide to us is basically they provide us the infrastructure and environments, they provide us the CI/CD, they provide us the networking. So they also have their own sidecar basically, and they all these machine learning models run behind this sidecar. So they are back then we had some TPA issues with them, but let's just say right now they're TPA compliant. And so they facilitate this connection to the service mesh that Mickey just talked about. What they don't provide is development and integration. Of course, that's our job. So they abstract away all these concepts, and as data scientists and engineers, we're just focused on developing our model. So, and for local development, they provide us with a sandbox CLI version, which basically helps us to do some integration tests, which lets us run our models locally behind their sidecar to ensure connectivity and to ensure that the payloads are being processed through the sidecar, for instance. They do provide the TPA connection now, like I mentioned. So TPA is the touchpoint architecture. So they provide a connection to the touchpoint service mesh. So in case we want to use some other microservices or models hosted there, we are allowed to. And they are very suitable for stated microservices, one in, one out kind of models. But now they're expanding, which we will cover in the next slide. This is their architecture as it stands now. They call it the United Model Platform or United Execution Platform. And basically, as we can see, that there is a centralized machine learning platform interacting with different components. When we deployed via them, they were providing CI/CD via GitLab, but with the organization moving to Azure DevOps, they are now moving their pipelines to Azure. And like we see that they provide these different lambdas, which are the model itself, and then we have the feature extractors, which in our case, for instance, was the preprocessor, because how it was different was the rest of the microservices received map data structures, dictionaries, pandas data frames, if you will, whereas our preprocessor received a binary, which was a bit of a issue back then, but now it has been resolved and it can happily accept binaries. Basically, it also has some metadata support. And so they have built this support for these feature extractors as well. For instance, another use case can be that our preprocessor needed to connect to a blob store, for instance. So all of that is covered here. Back then, and as we will cover in detail when we are talking a bit more about the central backend, is that we chose our own asset, our own VM for deploying the central app, because the machine learning platform did not have a support for multiple endpoints, API endpoints, but now they are providing that. Lastly, they are also going to be, and like I mentioned previously, they will be providing for the monitoring and logging of our applications, as well as the touchpoint registration of our microservices. But they will also provide as an or act as an interface to for services running on GCP. So they will facilitate running of models on our private cloud, but also on GCP if needed. And also everything that is hosted on GCP, we can interact with those models or those services via the machine learning platform. Next up, we will talk a little bit in detail about the central app, which we deployed on our own asset, which was a VM on our private cloud. And yeah, Mickey?
Yeah, so moving forward then to the deployment. You could go to the next slide, please. Yeah, so to recap, basically, our central application was a central backend that had no expensive task, as you could say, but didn't require some persistent storage. It was basically a Python application with running Flask, containing all the business logic. And we chose for this solution because we had this complex networking requirements of communicating both to the front end, which was on the front end server that had to go through the gateway. That was an NGINX web server. And it had, of course, communicate to all these models, which didn't have one specific, these were all stateless. So you needed to connect to something because the front end couldn't do this all by their own. So this solution, what it basically entails, you can go to the next one, was that we had to, so this meant that we need to be TPA compliant because, of course, the VM doesn't exist within this touchpoint surface mesh, but the front end did. So that meant that the entire backend needed to communicate in a TPA compliant way. So for us, that meant setting up a sidecar, and because a VM is just really like a duplicate machine, you could see this as running our application, which was the Python application, and then the sidecar in our case was a Java applet that runs on the side that acts as the barrier between all communication to the outside world. And we'll go into detail a bit about that later on. So this meant that CI/CD was our responsibility and networking as well. So I'll briefly explain what this deployment road looks like. And this is really from the bottom up to full production, basically, with, of course, all the operational stuff left out and all the compliancy. But that means for such an IT asset on a VM, you would need to, of course, have this machine. You would need to have all your required dependencies on there, and then do the required registration of your application to get the right certificates, because this is required for the touchpoint service mesh as well, especially for MTLS. And here in the middle, like these are the 5 steps, but in the middle you see basically the CI/CD part, which we did through GitLab and Artifactory. You could, but nowadays you can replace this quite easily with just a CI/CD pipeline from Azure DevOps. And this could directly push basically to your VM or any other solution that you would choose. On the right side, you would see basically all the networking requirements. So this is the API and service registrations and setting up the certificates. And this is basically the most work, because this is setting up the entire sidecar for being TPA compliant. And this is required if you actually want to do this deployment for yourself. Because of the time limitation, we don't go into too much detail right now what it means for the actual steps, and we have documented everything. So if you would like to see that, we can share that later on as well. But I think the more important part is that you would grasp a little bit on what it means to configure a sidecar, or what the sidecar actually does. So if you do have to do this, then here exactly on the right, you can see basically a very basic configuration of a sidecar, and this explains quite well all the key elements of your of the touchpoint surface mesh requirements. So all the way on the top, you would see that the application is in the producer. So this means that the central backend produces some APIs for others to consume. And we're using basically the application on the same machine as as our own application that we want to serve to users. So all the way at the bottom, you see the mesh port, and then all the way at the top again at the server port, you see the ports that are basically meshing each other together so they can freely communicate to each other on the same machine. You also see some SSL part here, some configurations. These are all the keys in the store, so you can see this as being your assistant. So the trust store is saying who are the people I can trust, and you give them maybe a social security number and a picture, like only talk to these people. And then the key store is like the confirmation who they or who you actually are and who they are. But the sidecar can be more way more than just basically a way to be compliant on the touchpoint surface mesh. So you can also see somewhere below that you can enable some metric support, so that the sidecar would already have support for logging capabilities through Prometheus, or maybe some other services as well. And yeah, that allows you to basically abstract away as much as possible with such a simple application. Unfortunately, if you do have to build this from scratch, you can quite easily isolate this entire application or Dockerized or just as a Java application. So it runs basically on every environment. So for us, this meant that the deployment road was a bit more difficult than it is now, because it was actually almost a year ago that we did this. So for us, we did it through GitLab, and then pushing our CI/CD through Artifactory, and then manually pulling it on a on-demand basis to the VM. And then it would work, but of course with DTAP, like with test acceptance and production environment, this is becoming a bit of a hassle. So we recommend, it's well documented now, to basically make full use of Azure, because your entire pipeline can quickly go through the CI/CD there without so many external dependencies. And then, yeah, we also have our final part of the application, the front end. And I'll keep it a little bit short here for the front end, because yeah, not everyone is too much interested in that, and we can have a whole talk about it in a separate meetup. But what's important to know here is that the application I'm describing is really a web app, or a progressive web app. So it can run without internet if you like, but more importantly, it has state, it can have user authentication, and it works on an ING standard way. So this is even not just by ING standards, by most internet standards nowadays. Web components are becoming more popular, where you can really abstract away from all the applications you're building, try to keep it really small and tiny, and then share them around in a plug-and-play kind of way. It also allows you to really reuse a lot of your elements that you're building. But for the networking part, we were fortunate to have, let's say, an existing infrastructure in place. So this is the front-end server, and that is because the front end is really tiny. It's like a static website once it's built, and it does mean that it's a bit unnecessary to host another VM, of course, and register your DNS for that, because you're never gonna fully make use of basically that VM with just a static website. It's just a few kilobytes that you need to send around to each client request. And that means that you can make use of some pooling, of course, so deploy everything on the same server and then handle the internal networking on that side. So we did that through the FE server and Fruit Loops, but that came with the requirement of communicating through this NGINX gateway.
All right. So thank you, Miki, for the very long discussion on the back end and the front end. So some parting words as we close this talk. And this is primarily useful when we are deploying some data science models particularly, and especially when we want to deploy like multiple components of them as microservices, and basically when we want to make them, fault tolerant and easily scalable. So some of the things that we found useful and we will keep in mind for our future development, and we just want to share with that. So first, share with everyone here. So first and foremost, we really urge everyone who is looking for this kind of a development to get a Hello World app running ASAP, using some kind of Jenkins or Azure DevOps pipelines, whichever is running in the organization or is of the preference. We should always keep scalability in mind. So that's why we urge everyone to work with microservices, because then it's really like your application is decoupled, and really one service cannot bring down the whole stack. And it would be nice to deploy via some container orchestration instead of a VM. This allows for like free scaling and really good fault tolerance. For some persistence and storage, we would prefer using binds and volume mounts, and we would encourage everyone to use that as well. We found them to be really helpful in our case, especially with some kind of document management, etc., and blobs. Most important thing that we realized was to how essential it is to work with centralized services. So whether it is a Redis database or an Elk storage or whatever, it is nice to reuse centralized services. They are already built for scale, and it can be a bit of a pain to onboard onto them and the operational aspects, but the rewards are very good. And like we discussed quite a bit through our entire conversation, that we should really think in detail about networking and security of our application. So we should really think about what kind of internal applications we are going to connect to, what kind of blob stores we are going to connect to, what kind of external network connections we have to allow, like to a front end or to a application hosted in GCP. Whether we are just going to produce, we are going to operate in a producer mode, or whether we are going to also operate in a consumer mode. So we have to think about all of these things, and accordingly the security part and the networking part. Then finally, we did manage to set up some monitoring stack for our services. But yeah, it is also important to think about that. So what are the things that we want to monitor, and how are we going to monitor them? Because we don't think about it, but it can take a significant amount of time for a developer or a squad. And lastly, yeah, we like to do it at ING, do your thing, and have fun developing your applications. Thank you very much.
Thanks a lot, guys. Well, we mainly have a lot of emoticons applauding your talk, and they're very enthusiastic. So thanks a lot. We have a question from Ali. How much or how long did it took you guys to go to production?
Miki.
Yeah, so I think one of the production timeline was really split between the applications. So once we went to, let's say, this microservice type of architecture, we could really isolate the deployment of each of these production roads. So for the front end, that meant that once we were basically in a test environment, we were also quite ready to go to production. So of course there were some feature requests besides that. And the same went for our model deployment. So the biggest bottleneck here was taking up the responsibility of using this VM and connecting it basically to all these different systems. So without that part, you could say theoretically it could have been done in 3 weeks, but for us we went into a usable, I think only testing phases after roughly a year almost.
I mean, like the core work, I think, for all of this was 6 months. A couple of months I also went in, for instance, monitoring and all these things. But like I said, like the core engineering part, including all the networking certificates and operational aspects, took about 6 months, I think.
And if you talk from idea to production, so from the first idea moment to go into production, how long did it take you?
Well, the POC was really fast. I think we managed to develop the POC, including all the feature requests and everything, in like 3 months. And then, yeah, like I said in the beginning of the talk, that was all monolithic. So another 1 month of breaking it down into microservices. So in like 3.5, 4 months, we were ready with the deployment. So our local POC or MVP even was ready. But getting it into a cloud was the real challenge.
Okay, thank you. Yeah, more thanks, guys, more emoticons. So let's give it a few seconds to see if anyone else has some questions. Again, nice work. Thanks for the display. I think we have some ING colleagues who are thanking you as well. I think we have a big ING crowd today. Yeah, I don't see any other questions. So thanks a lot, Mickey and Anand, for your talk. Really interesting. Yeah, so I think we will go back to John.